7.2 dot product, application of the dot product, mechanical. So what is a dot product? If you have two vector, the dot product of two vector is A dotted to another vector B. It is equivalent to the magnitude of the vector A multiply the magnitude of vector B multiplied by the cosine of the angle between these two vectors. Now, if you want to look at this picture to see what is exactly dot product, this is B, this is A. If you find the image of the B, the vector B on A, this is that side. So, which this side using the trigonometry is going to be your adjacent, right? So cosine is adjacent, cosine theta. Cosine theta is equal to adjacent. I call it AJ over hypotenuse, which is B. The magnitude of B. If you rearrange it for adjacent, it's going to be adjacent, going to be cosine theta multiplied by B. So it's B cosine theta. The image of that, so B cosine theta is image of B on vector A. And if you multiply it by A, and you multiply by the value of the A, magnitude of the A. So if the A or B is a zero vector, of course, if the A is zero vector or B is a zero vector, magnitude of the zero vector is zero, so the dot product will be zero. Or if the angle between these two vectors are 90 degree, cosine of the 90 degree, cosine of the 90 degree is zero. So if the angle between two vectors is 90 degrees, so you have a zero. So there's three cases: when A is zero, A dot B is zero; when B is zero, A dot B is zero; or when the A and B are perpendicular to each other. So here's the properties of the dot product. So U dot, if the U dot V is zero, then, and the U and V are non-zero vector, then these two vectors are perpendicular. So there is a commutative property. It means U dot V is the same as V dot U. And there is associative property when you multiply constant by U, then dotted to another vector V, then you can take the K constant out and dot U and V. Or you can bring the K constant beside vector V and multiply back there, and then you dot product it with U. There is distributed property. So U dot V plus W, so you can distribute that. So it's going to be U dot U plus U dot W. The same thing is correct. So if I U here, it's going to be U, the V dot U, then W dot U. U dotted to U is going to be magnitude of the U power 2. If you want to prove that, we know that the dot product going to be the magnitude of the first one multiplied by the magnitude of the second one multiplied by the cosine of the angle between them. If they are the same vector, so the angle is 0. So cosine of 0 is 1. It's just going to be U power 2. So U dot U is the magnitude of the U to the power of 2. Here, dot product of two Cartesian vector. So if we know this formula for the dot product, A dot B is magnitude of A multiplied by magnitude by B cosine of the angle between them. But if you have the component of the A and B, so it's going to be A multiplied by B, X component multiplied by X component plus Y component multiplied by Y component. If this is 3 dimension, then we have Z component plus Z component multiplied by Z component. And you add them. As you see, the answer of the dot product is a scalar, is a number. So this is an example. 5, negative 3 is U, V is 4, 7. Dot product of that, of course, you do X multiplied by X component, 5 multiplied by 4 plus negative 3 multiplied by 7. So you just add them and it's equal negative 1. So the answer is a scalar. Again, you have a 2 vector. The component is given. The dot product is going to be X component multiplied by X component plus Y component multiplied by Y component. If you do it, the answer is 2. If just the magnitude of the 2 vector and the angle between them is given, so you just say the magnitude of the first one multiplied by magnitude of second one multiplied by the cosine of the angle between them. It depends what is the given. either use this formula or this formula. Sometimes you're using both. Determine the value of the K so that the U and V are perpendicular. I know the U and V perpendicular if the dot product between them is 0. But the component is given, so 1 multiplied by K plus Y component multiplied by component, 3 multiplied by 7. So it should be 0. If they are perpendicular, means again, the dot product between them should be 0. Then you can rearrange it for K, and K is equal to negative 21. So the question that you can do here is number 1, A and B, or number 2, A, B, C, number 3, A, B, number 4 you can do, number 5, A, B, and C.